In order to talk about the process of dissolution, or things dissolving, we need to have a couple of vocabulary words down. And the main ones are solute, solvent, and solution. So the solute is the thing that you're going to dissolve, typically a solid like salt or sugar. And the solvent is the liquid that your solute is going to dissolve into. So if you're making salt water, the salt is your solute, the water is your solvent, and the solution is the resulting homogeneous mixture that comes from mixing a solute and a solvent. So in the example of salt and water, the solution is the resulting salt water. So when a solid dissolves in water, you see all of the solid disappear eventually. Sometimes you need to stir, sometimes it happens easily, but eventually all of that solid is no longer visible to the naked eye. It's still there, the compound hasn't disappeared, but it is no longer visible because it's dispersed and spread out so much throughout the liquid that you can't see it anymore. And visually, this gives you a solution that looks almost the same as the liquid as long as the initial color didn't change. So one additional vocabulary term that's worth knowing is solvation. When a solute is dissolved into a solvent, it's said to be solvated by that solvent. During the process of solvation, the solvent molecules surround each individual solute particle. And the reason why the solvent molecules are going to surround and interact with each of the solute particles is related to intermolecular forces and competing equilibria. And those are things that we haven't talked about yet, so we'll pass on the detailed explanation for now. But in short, the solute to solvent attraction has to be stronger than the solute to solute attractions or solvent to solvent attractions. This solvation process is probably best visualized when looking at an ionic compound that dissolves. So for an ionic compound, when it dissolves, the ions within it are solvated rather than the entire compound. This is part of the dissociation process for ionic compounds that are dissolving in water. So we'll look at the example of sodium chloride in water. Remember that this aqueous subscript for the sodium plus and the Cl minus ions refers to something that's dissolved in water, but maybe more appropriately, it refers to something that has been solvated by the solvent water. So if you take solid sodium chloride and dissolve it in water, it will split up into its ions, and those ions will be surrounded by water molecules. So in the example that I've just drawn, you can see that there's a sodium ion positively charged, and it is surrounded by water molecules, H2O molecules. And the oxygen part of the water is always going to be associated with that sodium ion. And we'll have to talk about partial charges and electronegativity and polarity and things like that to give a more complete explanation. But for now, it's important to note that one part of the solvent molecule is going to be associated with that positive charge. And in a second, you'll see that the chloride ion, the negative ion, is going to be associated with a different part of the solvent molecule. In the case of chloride ions, the negatively charged ion, you can see that the hydrogen atoms in the water molecules are the ones that are closest in interacting with the chloride ion. In this type of situation where the positively charged ion will interact with a certain component of the solvent and the negatively charged ion will interact with a different part of the solvent is pretty characteristic of the solvation process.